Alright, to get you ready for the quiz retake on polynomial multiplication and division, here's your last quiz that you took, and I'll run through it pretty quickly. The first problem here, that's just a multiplication problem. And so, just like when you multiply two binomials together, you have to distribute x, and then distribute 3, and then add up like terms. In this problem, we've got a polynomial with 4 terms times a binomial. So first we're going to distribute the negative 3x cubed, and we'll get negative 3x to the 5th plus 9x cubed. Next, I will distribute the negative 2x to both terms in the binomial. That will give me negative 2x to the 4th plus 6x squared. Then I will distribute the 4x, and I will get 4x cubed minus 12x. And then lastly, I'll distribute the negative 1, which will give me, I'll switch back to red again, negative x squared plus 3. So I've done all my distributing as I multiply the polynomial times the binomial, and now I'm just going to look for like terms. Okay, so let's see here. Like terms. So here's the next to the 5th term, and that's the only one. So that's going to be in my final answer, a negative 3x to the 5th. Next I'll look for x to the 4th terms. Okay, there's an x to the 4th term, and that looks like the only x to the 4th term I have. So that will come next, negative 2x to the 4th. What I like to do is, as I use up a term, I like to cross it out. Okay. Next I'm looking for cubic terms, because that's the next degree as I go down in order. So there's a couple of cubic terms, and I look at the sign in front of them. They're both positive, so I'd add them. It's 13x cubes. I'm going to cross those out. I'm ready for x squared terms. Ooh, there's a 6x and a negative x squared. So that means minus 1x. So that gives me a total of 6 minus 1x squared. Gives me a total of 5x squared. Then comes my x term. I only got one of those. Minus 12x. And then finally a constant plus 3. Okay, so there is my final answer. And that's all there is to it. Alright, now we're on to some division problems. Let me erase that little mark right there. Alright, so here's my first division problem. And the key thing here is, notice I've got this monomial on the bottom. A monomial means you don't have any addition or subtraction signs, okay? It's just 3x. It's a single term. And we talked about this in class extensively. For monomials, just take each term of your numerator and put it over that monomial. Essentially what you're doing here is dividing each term by 3x, which is exactly what the problem says. That's why everything's in the numerator. All of this stuff divided by 3x, and this is how you do it. Okay. Now it's just a case of simplifying each term. So 6 divided by 3 is 2, and we have x cubed over x to the 1st. I have an extra x squared in the top. I like to think of this as canceling, but you can also use the subtraction rule, where in order to do that division, I do 3 minus 1, which gives me x squared. 18, notice the sign just carries over. 18 divided by 3 is 6. Again, the exponent down there is 1, so I'm doing 2 minus that 1 gives me a 1. I just write that as x, but you can write it as x to the 1st if you want. Plus comes next. 3x over 3x, a lot of people put 0 for that, but we know from our fraction work from when we were younger that if your numerator and denominator agree, then you just get 1. Okay, how many 3x's are in 3x? The answer would be 1. And then finally, our last term, we've got a minus sign, so it'll be minus. 6 divided by 3 goes in there twice, and the x just stays in the bottom. There's no reason for it to move up to the numerator. If you did want to write it in the numerator, you'd have to write it with a negative exponent. So you'd have 2x squared minus 6x plus 1, and you could have gone 2 times x to the negative 1 power. But that x is in the denominator. Okay. Notice how, like in this term, we had an x in the numerator. That's because we have more up here. And so when we did the division, we had an extra x on top. In this last term, we have an extra x on the bottom, so it just stays there. Of these two answers I've written, I certainly prefer this one. And notice again that polynomial division, polynomial on top, polynomial on the denominator, is not closed under division. In other words, we didn't get a polynomial when we were done because we had an x in the denominator. All right, let me erase that little mark I just made there. I'm not sure why that happened. Anyway, let's go on to problem 3 now. Let's see here. There's number 3. All right, in problem 3, set it up high here. You'll notice this negative exponent, this negative 1 exponent. That means put me in the denominator, so this is a division problem. So this is x squared minus 8x plus 1 divided by x plus 1. Now I can't separate this thing and do what I did in the last problem because now I've got this binomial down here. It's no longer a monomial. So to do this problem, I'm just going to right away set it up like a long division. X plus 1 divided into x squared minus 8x plus 1. This is where a number of students start to have a little difficulty, but it is just long division. And when you do this, you're just asking a simple question. What do I have to take this first term by x? What do I have to take it times to get this first term, x squared? And the answer to that is just an x. Once I've decided on that, I have to take that answer and multiply it by my divisor. And I get x times x is x squared, and 1 times x is a positive x. Then I have to subtract that just like I would in long division. And so what's going on here is I get x squared, subtract x squared. That's 0x squareds, and I don't show it. It's negative 8x minus x. Okay, again, for some that may help if I put a 1 there to show you. And now you can see negative 8x minus 1x. That gives me minus 9x's. And I bring down my next term. Note the sign, it just comes with it. Now I'm going back to the very beginning kind of, and I just ask the same question. What do I have to take x times to go into this first term, which is negative 9x? Answer that by taking it times negative 9. And now I just repeat the procedure. I take negative 9 times my divisor, both terms. When I carry out that multiplication, negative 9 times x is negative 9x, and negative 9 times 1 is negative 9, and then again I subtract that line. I'll repeat this process, negative 9x minus negative. This double negative means addition. So I have negative 9x plus 9x. They cancel each other out. And I have 1 minus negative 9. That double negative makes it plus 9. And 1 plus 9 is 10. Now at this point, I can't take this x times anything to get 810. And so that's my remainder. When I write my remainder, I just don't put R10 you could put remainder 10. But in its best form, what we do is we say this division problem is equal to the x minus 9, the quotient, plus my remainder over my divisor. Remember, your x plus 1 is called your divisor, and so that is my best final answer. See if I can find problem 4 here. There we go. Problem 4, we can clearly see this is a division problem, so I'm going to set it up like long division right away. X plus 2, and I got to divide that into 2x cubed plus 6x squared plus 6x minus 8. I'm going to repeat the process I just did. I'm going to start by saying, what do I have to multiply x times to get 2x cubed? That's a 2x squared. And then I distribute that to my divisor. I get 2x cubed, and I get 2 times 2x squared and that would give me 4x squared, and then I subtract. Again, we have to be very careful with this subtraction right here. 2x cubed minus 2x cubed, they cancel. 6x squared minus 4x squared, that's 2x squared. I bring down my next term, 6x, and I repeat the process. X times what gives me 2x squared? The answer to that is 2x. And I distribute that to both terms. I get 2x squared plus 4x. Strike a line and subtract that. 2x squared minus 2x squared is nothing. 6x minus 4x is 2x. Bring down the next term all the way down here. Repeating again, x times what gives me 2x? The answer is 2. And I distribute that 2. Let's switch it to green so you can see me drawing that distributing arrow. 2 times x is 2x, and 2 times 2 is 4. And I subtract that line. 2x minus 2x is 0. Negative 8 minus 4 is negative 12. And that is my remainder, so I'm going to just go up here and put plus negative 12 over x plus 2. Plus negative 12 over x plus 2. So this whole thing is my final answer. Problem number 5 here. Problem number 5 was the most difficult one on there. We can clearly see it's a division problem. So I'm going to put x plus 1 out front. But when I divide into x cubed plus 1, I have got to put x cubed, let's make that a 3 right there. I've got to put placeholders in for terms that are missing. In other words, x cubed plus 1 does not have an x squared term. It does not have an x to the first power term, but it does have a constant. So underneath the division sign, I still just have x cubed plus 1 because these zeros don't have any value to them. 0 times anything is just 0. But by putting these space holders in there, it's going to keep my division problem lined up very well for me. So here we go. We ask ourselves, x times what gives me x cubed? The answer to that is x squared. So I put that up and I distribute. X cubed plus x squared, and I subtract. Being careful of the minus signs, x cubed minus x cubed is nothing. 0 minus, let's put a 1 here so you can see it, 0 take away 1 is negative 1 x squared. And I bring down my next term. The term I'm bringing down has a value of 0, 0 times x, but that's all right. We're going to let the math do its thing. X times what gives me negative x squared? I have to multiply by negative x. So when I carry out this distributing, taking the sign with it, I get negative x squared minus x, and I subtract. Negative minus a negative is negative plus. Those two negatives will make an addition, so the x squareds knock each other out. Here I've got negative times a negative, that's positive. I'm adding a plus 1 to a 0, so I get 1x. And I bring down the 1. What do I have to multiply x times to get x? The answer is 1, and I distribute that. 1 times x is x, and 1 times 1 is 1, and I subtract that. Hopefully you can see now I get x minus x is 0, I get 1 minus 1 is 0, and so I have no remainder. So this division problem comes out to exactly x squared minus x plus 1 with a remainder of 0, so I don't even show it. It divided evenly, x plus 1 divided evenly into x cubed plus 1. Alright, now my last problem did not copy over when I put the worksheet on here, so I'll just write down what it is. It says, this is number 6, it said f of x equals 3x cubed minus 4x minus 1. And the question was, is x minus 1 a factor of f of x? There's two ways to do this. The long and difficult way is to actually use division. Divide x minus 1 into f of x. So you could actually carry out this division problem and find out, does it go into it evenly? Now when you do this, you'd have to be very careful. There's no x squared term in this polynomial, so you'd have to put in a 0x squared to hold that spot. And then you'd carry out the division. I'll go ahead and do this quickly, just so you can see it in action. Interesting. I was hoping, there we go, slide that out of the way. And move this all up a little bit. So I'll carry out this division really quickly. 3x squared gives me 3x cubed minus 3x squared. Subtract that line, gives me a positive 3x squared because of the double negative. Bring down the negative 4x. Take it times 3x so that I get a 3x squared minus 3x. Subtract this. Right here I'm going to get a double negative, making it positive. So it's going to be a negative x when I get done because negative 4 plus 3. Bring down the negative 1. Take it times negative 1. Subtract that and I get negative 2. I got a remainder of negative 2, so the answer is no. X minus 1 is not a factor of f of x because it does not divide into it evenly. That's the long way to do this problem. I would use the remainder theorem to actually do it. Remainder theorem says if x minus 1 is a factor of a polynomial, f of x in this case, it says this. Let's write it down. If x minus 1 is a factor of f of x, then the f of 1 will equal 0. It's not exactly what the remainder theorem says, but that's how the remainder theorem would be applied to it. The remainder theorem actually says that if I divide by x minus 1, plugging a 1 into this function will tell me the remainder if I were to divide by x minus 1. So that's what I'm going to do. I'm going to find the f of 1, and that will tell me the remainder when I divide by x minus 1. So I'm going to plug 1 into the function. So I'm just replacing all the x's in f of x with 1. And I'm going 1 cubed is 1 times 3 is 3 minus 4 minus 1. And continuing, I get negative 1 minus 1. I get negative 2. Look at that. That was the remainder. That's the remainder theorem in action. So what it tells me right away, just by plugging in positive 1 into the function, it tells me I'd get a remainder of negative 2 if I were to do all of this division work. And since I have a remainder of negative 2, no, it's not a function, or it's not a factor of that polynomial. I'd need a remainder of 0 in order for myself to have a factor. All right, I hope that helps. Kind of wordy and kind of long, but each problem is gone through.